Hey guys, today we're going to be going over this foldable that we did in class today, January 27th, it's a Thursday, about the special cases. So if you remember, we've been going over equations like this, the 3x plus 4 is equal to x plus 8, and we've been doing our legal moves to try and solve for x. Remember we said a solution is the value for x that will make the two sides of the equation equal to each other. Okay, and so far, everything that we've done has had a very specific one solution, right? X equals something. So now we're going to start talking about special cases where we might not have a solution or we might have infinite solutions. And if we think about the word infinite, that means never ending. So that means any value would make both sides equal there. Okay, so like I said, we've been doing ones that have one solution. Okay, so if I make all of these empty boxes an x, all right, on my left side of the equation, I have 4x's, so 4x, and that is equal to 2x plus 6. All right, now to solve this, I would do my matching sets and think, what do I have on both sides that I can take away? And I know that I have 2 x's on both sides. So I'm going to take away those 2 x's. That's a 2, I promise. That looks really weird. Okay, so once I take 2 x's away from here, I have 2x is equal to, those cancel out. So I have just 6 over here. 2 x's are equal to 6. So I'm going to split those 2 up by dividing them. So 2 divided by 2 is 1. So I just have x is equal to 6 divided by 2 is 3. Okay, so I would have an x tile here and 3 1s, and it would be balanced. Oh, you can't see that. There we go. Okay, so that would be balanced. All right, so when we are able to get x alone and equal to a number, like x equals 3, then that is the solution. There's just one. Okay, so my solution to this is x equals 3. Okay, but sometimes it won't always end up with a specific answer like x equals 3. So now I'm going to move over to this middle, this no solution here. And again, I'm going to put an x for both of these empty boxes. So on the left, I have x plus 3. And on the right, I have x plus 5. Now you should already be thinking in your head that looks a little bit weird. So something plus 3 is equal to that same thing plus 5. That sounds weird. So a little red flag should already be going up in your head. But if we think about our legal moves and how to solve this, first, I could take away either the x's or the 3. So I'll just take away the x's first. And I get 3 is equal to 5. Okay, I already know that that's not true, but I can still do some matching sets. So if you just left it at that, that would be fine. Or if I took away 3 from both sides, then I would have 0 equals 2, which we still know is not a true statement. Okay, so whenever I end up with that false statement and one side is heavier in terms of like the scale, then we have no solution. Okay, so thinking about what a solution means, that means that no value for x would ever make this true. So just to be sure, let's go ahead and test out a couple numbers to make sure that none of them work. So let's say that x is 2. Okay, on the left side, I would have 2 plus 3, which is 5. Then on the right, I would have 2 plus 5, which is 7. Obviously, those are not equal to each other. So 2 could not be a solution. Okay, but what about maybe 0? So over here, I would have 0 plus 3, which is 3. On the right, I would have 0 plus 5, which is 5. So I end up with 3 equals 5. And again, we know that that's not a true statement. 3 does not equal 5. Okay, but maybe what about a negative number? So let's try negative 3. On the left, I would have negative 3 plus 3, which we know is 0. On the right, I have negative 3 plus 5, which is 2. So I end up with 0 equals 2, which again is not a solution. Is not a true statement, excuse me. So that means that there is no solution for this equation. All right, so when the x's disappear, and one side is bigger, there is no value for x that would ever make both sides balanced. Okay, so that's when we have no solution. All right, and our final special case is infinite solution. So remember we said infinite means that literally any number could work. All right, so again, one last time, I'm going to make both of these empty boxes an x. So on the left, I have x plus 4, and on the right, I also have x plus 4. So again, already you should be having a little red flag going up in your head because this is the exact same thing. So obviously they're going to be equal, right? But using my matching sets, I can take away 4 from both sides, and I would end up with x equals x. So again, think about that. A number equal to the same number. No matter what that is, it's always going to be true, right? So matching sets, I can take away an x from both sides, and now I have 0 equals 0. And think to yourself, is there ever an instance where 0 would not equal 0? No, right? 0 is 0. That's what it is. So we end up with a tie. That's an IE, I promise. Tie. All right, so when the x's disappear, okay, notice how I was able to take away all the x's and just end up with 0 equals 0. So when x's disappear and both sides of the equation are equal, any value for x would make the equation true. Okay, so just to double check to make sure that we're correct and that any number would work, let's go back up to our original equation here. Let's just try, let's say x is equal to 3. Okay, so I've got a 3 there and a 3 there. On the left, I have 3 plus 4, which is 7. On the right, I also have 3 plus 4, which is 7. That's a true statement, so that's good. Okay, well, what about 0? On the left, I have 0 plus 4, which is 4. On the right, I also have 0 plus 4, which is 4. Again, that's a true statement. So 0 and 3 both worked. Now, what about a negative number? Say I tried negative 1/2. That's fun. Okay. Negative 1/2. Negative 1/2 plus 4 is negative. Oh, geez. Excuse the people in the hallway. Oh, wait. Just kidding. That would be positive 3.5. And on the right, I also have positive 3.5. Okay, so that still works. So any number placed in for x, substituted for x, would work. So that means that we have infinite solutions. So if you get this on a problem, this is not your answer. Your answer is infinite solutions. Okay, so these are our three special cases. In class, we glued this onto page 26 of our notebooks. So just put glue on the back of the no solution part here. And then we just glued this onto page 26 so that it can still close up inside of your notebook. All right, so those are the special cases. Once we went over those, then we finished problem D on page 25, which is a special case. And then we went ahead and started working on page 27. So look out for videos going over those pages. And hopefully this is all making sense to you.